Hello everyone, I am Siping Gao from Nanjing University of Aeronautics and Astronautics, China. Today, I will introduce a novel EMI protection device known as the Ferrite-Based Frequency Selective Limiter. Advances in wireless communication and sensing have created increasingly dense EM environments, making modern RF receivers more vulnerable to interference. Traditional protection approaches such as power limiters and frequency-selective surfaces face key limitations including indiscriminate attenuation, added power consumption, and a large physical footprint. Ferrite-based frequency-selective limiters, or FSLs, provide a passive, adaptive, and low-profile alternative. Leveraging the low-loss, magnetic tunability, and strong nonlinearity of ferrite materials, FSLs can automatically suppress high-power interference while preserving the desired signal. This makes ferrite-based FSLs a promising solution for robust and real-time EM protection in next-generation wireless systems. Let me highlight a few recent advances. First, since FSLs depend on high-quality ferrite thin films, we developed a fast characterization method that simultaneously retrieves the key material properties in a single measurement. Next, a scalable circuit model was introduced to support efficient and flexible FSL design. This model enabled the creation of an ADS simulation deck for streamlined optimization. Finally, recent work has focused on miniaturizing the magnetic biasing system using permanent magnets and microcoils, making FSLs more compact and easier to integrate. Let me show you a demo illustrating how a ferrite-based FSL can protect a GPS receiver from EMI. Before ending my 3-minute presentation, I'd like to show you the outline of the full presentation. Thank you.